Okay, 8.4, we start talking about angles of elevation and angles of depression, and we're going to use trigonometry to find out what the angle of elevation and angle of depression are. But before we do that, I want you to try these 3 questions in the warm-up, write them down, and pause the video. Here are the answers. If you didn't get them correct, then you probably should go back to the video for 8.3. So again, the objective is to solve problems involving angles of elevation and angles of depression. And what is an angle of elevation and angle of depression? Well, here's a really good picture. An angle of elevation, this guy in the airport tower is looking up at the airplane. And if you notice, this dashed line is the horizontal line. It is always parallel with the ground. And that's, since he's looking up, this angle in between the horizontal line and his line of sight, that's the elevation. This guy in the airplane is looking down at the airport tower. And again, here's another parallel line. This is the imaginary horizontal line. It's always parallel with the ground. And this guy is looking down. So this angle right here is your angle of depression. Depression means down, going down. Angle of elevation means going up. So the definition is written right here. The angle formed by a horizontal line and a line of sight to a point above the line. So you're looking up. That's elevation. Depression, you're looking down. It's below the horizontal line. So this one's above the horizontal line, below the horizontal line. That's how you can tell. And if you notice, these 2 horizontal lines are parallel. So what can we say about angle 1 and angle 2? Well, they have to be congruent because they are alternate interior angles. So they are congruent. And that's going to be important for what we're going to be doing, the problems we're going to be doing. Solving angles of elevation and angles of depression. Okay, so the first type of question, super straightforward. It says classify each angle as an angle of elevation or an angle of depression. So all you have to do is look at this picture and think, well, are we looking down or are we looking up? So if you look at angle 1, here's angle 1 right here. It is below the horizontal line, so it is an angle of depression. If we look at angle 2 is this angle right here. If you look, it is above the horizontal line. The horizontal line is the dashed one, so it is an angle of elevation. Angle 3 is this one right here. It is below the horizontal line, just like angle 1 is, so it is also an angle of depression. And if you look at an angle 4 is above the horizontal line, just like angle 2 is. So angle 4 is also an angle of elevation. Okay, so it's really important that you recognize the differences between angle of elevations and angles of depression. So you're going to try this. This is the first question that you're going to try tonight. I'm going to check it tomorrow. So you're going to try, you can title this number 1. You can call it 1A and 1B if you'd like. It's same thing. Looking at this picture, either tell me if the angle is angle of elevation or angle of depression. Okay. Now that we know what the difference is between angle of elevation and angle of depression, we can do some real-world problems. So the Seattle Space Needle, I've been there. It's pretty cool. It casts a 67-meter shadow. That's 67 meter sticks. So that stick I am always waving around in the class, 67 of them. Put them together. That's how big the shadow is. If the angle of elevation from the tip of the shadow to the top, to the top of the Space Needle is 7 degrees, how tall is the Space Needle round to the nearest meter? So they're going to give you this word problem. They're not going to give you a triangle. So if you wanted to draw a triangle, you're more than welcome to. But let's say here's my Space Needle. I know, artist. So good. There's my Space Needle. Okay, and then we're going to fill in the notes. If the angle of elevation from the tip of the shadow, so here's the shadow right here, and it says angle of elevation. Notice this is the horizon. The floor is also could be considered the horizon. So angle of elevation means it's above. So it's 70 degrees. And we know that this shadow is 67 meters long. So we know that this shadow is 67 meters long. We want to figure out how tall is this Space Needle, because again, it would be really dangerous if you took your meter stick that you always walk around with and tried to climb up the Space Needle and see how many meter sticks it is. So we're going to use trigonometry instead and be a little safe. So first thing you need to figure out is, are you going to use sine, cosine, or tangent? So SOHCAHTOA, TOA, which one is it? Well, in respect to this angle, we have the opposite side, because it's not touching it, and we have the adjacent side. For the most part, I'll give you a hint. For the most part, it's going to be tangent. It won't always be tangent, but for the most part, it will be. So we're going to use tangent. So we know tan of the angle is always the same as opposite over adjacent. Then we fill in our notes. The angle is 70 degrees. We know that the opposite side is the height of the Space Needle. We don't know how long it is, but we know the shadow, the adjacent side, is 67. And then the opposite of dividing by 67 is multiplying. So you literally put this into your calculator, and that's how long the Space Needle is. If you don't put it in this way, and you wanted to put it in this way, make sure you put the parentheses around your calculator. Otherwise, it's going to give you the wrong answer because you put it in wrong. So the height of the Space Needle, that is really majestic, is 184 to the nearest meter, 184 meters long. Tall, excuse me. That's pretty tall. That's 184 meters 6. That's pretty tall. Okay, that's one question they can give you. There's lots of questions. I'm going to do 2 more with you, and then you'll have 1 to do. Okay, so this one I didn't put the triangle on here so we can get used to drawing. It says, suppose the plane is at an altitude of 3,500 feet, and the angle of elevation from the airport to the plane is 29 degrees. What is the horizontal distance between the plane and the airport? So we've got to draw our airport. I'll put PSP, Palm Springs Airport. And we have our airplane. Of course, the airplane is up in the sky somewhere. So there's our airplane. Okay, and it says that it's 3,500 feet. It has an altitude of 3,500 feet. So that means it is 3,500 feet up above the floor. Okay, so here's the floor, the horizon, if you will. Okay, and it says that the angle of elevation from the airport to the plane is 29 degrees. So if here was the airport, and it was looking up, excuse me, like this, it would be 29 degrees. So what is the horizontal distance between the plane and the airport? Again, I know it's up here because if you were here, you were looking up at the plane. And angle of elevation is always above the horizontal line, which is the parallel one. Okay, so we want to figure out how far away is that plane before it lands at Palm Springs. So again, we have to figure out, is it sine, cosine, or tangent? That's hard for me to do. So is it SOHCAHTOA or TOA? Well, in respect to the 29 degrees, the height of the airplane is the opposite side, and the width, or the distance is the adjacent side. We don't really care about the hypotenuse. So we're going to use tan again. So tan theta equals opposite over adjacent. And then we fill in our knowns. And then we solve for our variable. And this time x is in the bottom, it's on the denominator. So what do? We swip it, and we literally put this into our calculator, and it tells us that the distance of the airplane is 6,300 to the nearest foot, 14 feet away. Okay, so a little bit more than a mile away. Pretty cool. Good information. Super important to know if you are somebody who's working at Palm Springs International Airport, or if you are the pilot or the hostess. What's that called? No, stewardess on the plane. Okay, I'm going to give you another one, and then you're going to try one. These word problems are hard because it's drawing the airplane. It's drawing the triangles that's tricky. Okay, we have an ice climber. Woo, super cool. Stands at the edge of a crevice. It's like a cliff, kind of. And it's 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. How deep is the crevice at this point? So a crevice is like, it's like, a cave underground. Okay, so this ice climber is standing at the edge of this crevice, and this crevice is 115 feet wide. The angle of depression, that means it's below the horizon. So there's my parallel horizon. Angle of depression from where she stands. So this is where she's standing. To the bottom of the crevice is 59 degrees. Now this is important. Okay, this is where some people are going to goof up. The angle of depression, remember the angle of depression is below the horizon. So this is 52 degrees. And we want to know how deep is the crevice. Okay? So that would be x. All right, so here's all the information. This is super important that you understand this is the angle of depression, not this one. Because what is this angle really going to be? Well, this is a 90-degree angle. So 90 minus 52 is what, 38? So this angle is now 38 degrees. And we can use the 38 degrees to help us solve this problem. So again, we have to think, are we going to use sine, cosine, or tangent? Well, wouldn't you know it, we have the opposite side and we have the adjacent side again. So we're going to use tan again. So tan of 38 equals opposite over adjacent. Tan of 38 equals 115 over x. We swoop them since x is on the denominator. And you have x equals, I'm sorry, I'm going to go over here. X equals 115 over tan 38. And what is that going to give you? It's going to give you the how deep that crevice is, so you know how much you have to scale it and stuff. I've never ice climbed, but that's assuming you need to know how deep something is. So it's 147 feet deep. So she's going to climb down 147 feet in the ice. Sounds like fun. Sweet. All right. So like I said, for the most part, it's going to be tangent. It won't always be tangent, but for the most part, it will. Okay, so I want you to read this example. Try it on your own. This is a tricky example. This one's tricky. You're going to title this one number 2, and you're going to remind yourself that this is kind of tricky. Do this question. We're going to do it in class. See if you get the correct answer. And then, oh yeah, we'll do this one in class too. So this one will be number 3. This is tricky. Oh, I feel kind of bad. Okay, I'll do this one with you guys. I'll do number 3 with you guys. Okay, so a pilot flying at an altitude of, I'll draw the pictures for you guys. Okay, so a pilot is flying at an altitude of 12,000 feet. That's how far up this pilot is. He sights 2 airports right in front of him. So here's one airport. Here is another airport. Okay, the angle of depression. So here's the horizon. Remember, depression means below. To the first airport is 78 degrees. So this is 78 degrees. Okay, and what you're going to want to find, excuse me, this triangle is kind of beyond horrible. There's that. So this angle right here is 78 degrees. We want to figure out how far away is he from the first airport, or she, excuse me. The second one says the angle of depression to the second airport is 19 degrees. So I'm going to draw that in black. So here's the horizon again. Okay, angle of depression. So his line of sight, or her line of sight, to the second airport. This angle of depression right here is only 19 degrees. So you guys have 2 triangles here, and you want to figure out how far away is he from the second one. Okay, so what's the distance between the 2 airports? Okay, so that's the ultimate question that you're trying to figure out. What's the distance between the 2 airports? This is a tricky question. I'm going to redraw the triangles for you, okay? This is the distance to the first airport. I'll call it number 1. We don't know how far away it is, but we know that the airplane is 12,000 feet up, and that the angle of depression, this one right here, is 78 degrees. Sorry, I know this is small. The other one, the distance to the second airport, the angle of depression, notice how my voice is getting higher because it's super important, is 19 degrees. That's this angle. Okay, and he's 12,000 feet up still. Didn't change. So how far is this one? How you do it is you find the distance from the first airport. Find the distance from the second airport. Last thing you do is you subtract those 2 answers. And that's how you find the distance between the 2 airports. So do this for number 3 and number 2. Have a wonderful evening, and remind yourselves what's the difference between angle of elevation and angle of depression.